Hello everyone, I'm Arindam and today's topic of presentation is using different sensors in Flutter. So let's start with the overview of sensors in Flutter. Modern smartphones come equipped with a variety of sensors that enhance user experience by detecting motion, environmental changes and interactions. Flutter allows developers to access these sensors to create dynamic and interactive applications. How sensors improve app functionality? Motion detection, used for fitness tracking, step counting, and gesture-based control. Navigation and orientation, essential for maps, AR/VR applications, and gaming. User interaction, detects proximity, screen orientation changes, and device movement. Environmental awareness, measures light, air pressure, magnetic field for smart automation and weather application. So, have you ever noticed if we rotate our phone, it changes the screen's orientation? Or have you ever noticed if we are on a call with someone and we place the phone close to our face, the screen of the phone it shut down, and why it's happening? Or have you ever wondered if you are using the auto brightness feature of your phone, the screen's brightness it automatically get adjusted according to the light of your room. So in all these scenarios, what's happening is there is a sensor in your phone that is controlling all these changes. So like for the phone, if you're on a call with someone and you place your phone near your face, it uses a proximity sensor that detects something is near me. So it shut down your screen for accidental touches and to prevent accidental touches. Similarly, when you use that auto brightness feature, it uses a light sensor present in your phone that takes the light intensity value, and due to that light intensity value, it then decides what should be the brightness of the screen. Or if you tilt your device, there are gyroscope and accelerometer sensor in your phone that detects the orientation of the phone, that detects in which position your phone is currently in, and then decide which orientation should it display on the screen. So yeah, all this happens because of some sensor in your phone. So the next question is, why use sensors and Flutter? So sensors plays a crucial role in enhancing mobile application by enabling real-time interaction with the physical world. Flutter allows developer to leverage these inbuilt sensors to create smarter and more responsive application. So yeah, as I have just discussed about how many sensors there that you are using continuously in your day-to-day life. So it becomes important to know about the sensor, and Flutter allows you that you can use these sensors and create and use them in your apps. So let's go through some different sensors. Let me tell you about some sensors one by one. So the first sensor is accelerometer. It measures acceleration along three axes and detects movement used for step counting, shake detection, and motion-based controls. Gyroscope. It tracks rotational motion, helping in precise orientation detection, essential for AR/VR and gaming applications. Magnetometer. It detects Earth's magnetic field and helps determine direction, used in compass and navigation applications. Light sensor. It measures ambient light levels and adjusts screen brightness accordingly. Helps improve battery efficiency and user experience. Barometer measures atmospheric pressure to determine altitude, used in weather apps and GPS for better elevation tracking. And the last, proximity sensor detects objects near the screen to turn it off during calls, used to prevent accidental touches and save power. So all these sensors, we are going to learn about them and implement them. So let's deep dive into our first sensor, accelerometer. What it detects motion and tilt. So the accelerometer is a motion sensor that measures device acceleration in three axes, X, Y, and Z. It detects linear motion and helps determine the device orientation based on gravity. How it works: measure changes in velocity when the phone moves or tilts, output acceleration values in meter per second square or g forces, works in combination with the gyroscope for better motion tracking. So yeah, let's implement this accelerometer in our Flutter app. for this, I have created this Flutter app, and you need to first install a package, this Sensor Plus package. Let me show you. Yeah, you can just install the any version that is compatible with you. I'm using I'm using the latest one. So yeah, you can just copy it from here and paste it in your pubspec.yaml file, how we use the dependencies. And after you paste it, just run this command, flutter pubget. Or you can just click here and it will just automatically download the package, and you will be able to use it in your app. So now let's start writing the code. So currently, when I click on the accelerometer card, it will not change anything. It will just give us the 00 value because I have initialized these values and I'm just printing them. I'm not doing anything different here. And I have just created these components using a stack widget. I've just used a circular widget, and I've just stacked another circle on top of it. So yeah, it's nothing fancy. So let's just quickly implement our accelerometer. Okay. So yeah, this is the method that we'll be using. Wait, let me initialize it in the init state. And as you can see, this is a deprecated one, so just use this one instead. Okay, let's replace it. Okay, so yeah, it's fine, I guess. Now let's restart our app for once. Go to debug console. And yeah, our app has been restarted. Now let's try. Okay, now can you notice one thing? I gave the initial value of y 0.0, but it's not 0.0. Earlier it was the all values were 0, but now the y values is not 0. So why? What's happening different now? So actually it's using a accelerometer sensor, and it's projecting the value of that accelerometer. So let me quickly show you. Just go to virtual sensors, device pose, and here you can see the value of accelerometer in y-axis is 9.81. Right. Wait, let me. Yeah, and that's what it's printing right here. So it measures the linear velocity, linear velocity change, that is acceleration. So you can basically, can you see the x value changing when I'm moving my phone? Or can you see the y value changing or the z value? In all these situations, here the value is changing because accelerometer sensor can sense the change, like the acceleration of the phone in all the values. Now let's try rotating it. Can you see as I'm rotating it in a z direction, my values are changing, and if I rotate it enough, it will change the orientation of the screen. This is how our screen orientation actually works. It uses an accelerometer sensor in the back, and it decides which orientation should be on the screen currently. And let's fix this. Yeah. So this is how you implement the accelerometer sensor. Just import the package sensor plus. This will give you the accelerometer event from which you can. Here I have created a stream subscription so that I can continuously update my values. And with this stream subscription, I have just called the accelerometer event.stream.listen. This .listen method have a function on data which contains the accelerometer event values. Uh, I'm just assigning these event values, the values that are coming from the sensor, to my variables here. And I'm just using a set state so that I can show it in the UI too. What set state does, it just rebuild the build method. So yeah, and after that, always remember if you're using any subscription, stream subscription, always remember to cancel it in the dispose method so that it won't give any state errors later. So yeah, let's now quickly move to our next sensor. Our next sensor is a gyroscopic sensor. So what gyroscope is? Gyroscope is a sensor that measures rotational and angular velocity. The gyroscope is a motion sensor that detects rotational movement around three axes, x, y, and z, pitch, roll, and yaw. It provides precise angular velocity data, allowing for accurate motion tracking beyond what the accelerometer can achieve. How it works: measures the rate of rotation, angular velocity when the device is tilted or rotated, uh, output values in radian per second square per second, and works in combination with the accelerometer to enhance motion detection and provide smoother orientation tracking. So gyroscope is similar to accelerometer, but it is used to detect the rotational changes. It is used to detect the rate of rotation, that is the angular velocity, and it gives output in radian per second. So now let's quickly implement gyroscope 2 and our FlutRap. So let me first show you the gyroscope pick card. Yeah. Currently, it's not changing with any rotation, as you can see. If I rotate it, you can see the change of values in the gyroscope here, but it's not getting changed in our app UI because currently I have not used any method, or I have not used the sensor values. So let's start with that. For this also, you can just use the sensor plus package. This package gives you access of gyroscope 2. So now, yeah, let's implement this. Void stop gyroscope. Yeah. Again, this is a deprecated one and shouldn't be used, so just use this gyroscopic event stream. Always try to not use the deprecated methods if there is an alternative. So yeah, I think it should. Oh yeah, we have to first initialize it, so that in init state, when the app opens that page, it will initialize this method and it will start listening to our gyroscopic sensor values, which I'm just using and assigning to these variables, and I'm using set state so that it gets reflected in our UI too. So now let's test it. Let's first rerun our app once. Okay, yeah, it's worked. Let's go to gyroscope. It's still showing 000, but what happened if I change the, okay, can you see the change here? Now it's showing the angular velocity with which our phone is moving, right? You can actually do a lot of things using these values. Here, as you can see, this is how gyroscope works. Okay, now let's just go to our next sensor. So our next sensor is magnetometer. It detects magnetic field and orientation. The magnetometer is a sensor that measures the strength and direction of magnetic field around the device. It helps determine the device orientation related to the Earth's magnetic field, making it essential for compass and navigation applications. How it works: detects the presence and intensity of magnetic field in microteslas, measures the device alignment with the Earth's magnetic field to determine device direction, works in combination with the accelerometer and gyroscope for precise orientation tracking. So let's quickly move to our next sensor. What magnetometer does is it uses the Earth's magnetic field, and with the help of Earth's magnetic field, it will tell you which direction you are currently in, or rather, which direction the north is. So for that, I have just created a simple UI. Let me go to magnetic screen. it is not moving and it's just pointing to a random direction. Let's try if I, okay, let's try moving our phone. Can you see the change in magnetometer values? But as always, it's not reflecting because we have not implemented it. We are not using these sensor values. So let's quickly use this. For this, for magnetometer also, you can just use the Sensor Plus package. From Sensor Plus package, you can use the three sensors. First one was accelerometer, the gyroscope, and magnetometer. So yeah, let's just quickly add start magnetometer. Yeah. Okay, it's saying magnetometer stream. Listen isn't defined for the type function. Track it. Okay, so I think it will just, yeah, it's working now. Okay, now let's call this here start magnetometer. Let's restart our app once so that it gets loaded properly. Yeah. Okay, now can you see the change in values? First, it was just pointing at a 0 heading. Now it's pointing at some degree. Now, because our phone is currently at an orientation, now if I change the orientation, you can see the change in heading 2. So if I am pointing here, it will point the north is straight up ahead, right? You can also change, like because it's an emulator, you can also change the magnetic field from here. So like if I increase the degree, you can see the change here also. Let's just quick reset it to 0. Yeah. So this is how magnetometer works. Let's quickly go to our next sensor. This was the implementation of magnetometer. You can just use these from heading value. You can like it will give you value in x and y. You can then convert it to your heading and just store it in your heading variable that you have created. Okay, now let's see the proximity sensor. So what proximity sensor does is it detects nearby objects. As the name suggests, it detects if something is in the proximity, right? The proximity sensor detects the presence of objects near the device without physical contact. It is commonly used to determine if an object like a hand or a face is close to the screen, allowing apps to trigger specific action based on proximity. How it works? Emits infrared light and measures the reflection to detect nearby objects. Basically, it takes the time as a parameter, how much time it takes to the infrared light to return to the screen, and then it estimates the distance. Output values as near 1 or far 0 based on object proximity. Works efficiently for short range detection, typically a few centimeters. Implementation of proximity sensor. Now let's quickly implement this sensor. For this sensor, what we can't use is we can use the Sensor Plus package. For this, we have to install a new dependency. It's this, the proximity sensor dependency. So let's quickly copy it here. You can always check the versions. So it currently needs just 2.12. It's a very old minimum data SDK version. So I'll guess the newer version, like the latest package version, will run fine on your device too. Yeah, just here. I have copied it in my dependencies in my prospect.yaml. After that, just run flutter pub-get so that the dependencies get installed. Or you can just click here to package proximity sensor. Sorry. Now let's just quickly wait, event. It's not working. Let's see the dependency. Okay, so it uses a proximity sensor dot events dot listen, and we have to use it exactly like this. proximity sensor dot events dot listen. Yeah, it's not giving any error. Let's see if it's working. Start proximity sensor. Just restart your app once. Go to debug console. Okay, so proximity sensor. Okay, it's showing all clear. But can you see it changes when I increase the proximity? Okay, so I know what mistake I made. Let's go to PPT. Can you see here? Output values near is 1 and far is 0. And here I am asking is near to be true when its event is equal 0. So let's just change it to 1 so that it works properly. Let's just restart it and go to proximity sensor. Now it's showing all clear because it's currently at 4.3 centimeter. If I reduce it to less than 1, it will change to object detected. And you can here apply different functionality and just showing it on display. Yeah, you can. This is how you use this sensor. Okay, now let's go to our next sensor. It's barometer. So what's barometer? It measures atmospheric pressure. The barometer is a sensor that detects atmospheric pressure, allowing devices to estimate altitude and weather changes. It is commonly used in navigation, fitness tracking, and weather forecasting application. How it works? Measures air pressure in hectopascal or millibars. Detects altitude change by analyzing variation in pressure. Works in combination with GPS to improve elevation accuracy. So yeah, it's important for us to learn about this sensor specifically because in our KML we use altitude. We have to give which altitude you use. So it might come handy later if you are working with liquid galaxy rig. So yeah, let's quickly implement this barometer sensor. Okay, so for barometer also you have to install a different package. This flutter barometer, just use the flutter barometer and you can add it. Let me show you. Yeah, here, just add this flutter barometer with this version and it will work. You need for this package you have to do one more thing. You have to include namespace in this package. So because it's a very old package, so let me quickly show you that also. Just go to C users, app data, local, pub, cache, hosted, pub.dev, and here you have to find, like, just remember this path uh, and just go to Flutter Barometer, the package that you just installed. Or before that, remember to run the flutter pubget command because otherwise it won't come here. So yeah, here is the Flutter Barometer package. Just go to it and in Android build.gradle here. Okay, yeah. So in this file, just copy the group's name, copy the whole thing, and just inside Android, just add a namespace and paste it here, the group's name. And after that, just save it. And after that, you have to run the three commands: flutter clean, that will clean your dependencies; flutter pubget to reinstall the dependency; and flutter pub upgrade to see if there's any upgrade for the dependency. And yeah, after that it just restart, like rerun your app, and this will work. Now just let's quickly just import this package and then I'll show you how to use the barometer. Okay, just start barometer, but it won't work. So obviously this is not the implementation. So for this you have to use the flutter barometer events.listen and a flutter barometer event object. Okay, so here it will be a flutter barometer events and instead of barometer event, it will be flutter barometer event, right? And always, yeah, just remember to initialize in your init state. Just restart your app. Now let's check our barometer package. The pressure sensor. Yeah, it's showing some pressure. Now let's try changing it. Now, as you can see, the pressure is changing according to the pressure of our sensor, like this. And this value can be used to estimate the height, the altitude of a person. So yeah, it's a very handy sensor. Okay, now quickly let's go to our next sensor. So our next sensor is the light sensor. It detects the ambient light intensity. The light sensor measures the intensity of the ambient light around the device. It is commonly used to adjust screen brightness automatically and optimize power consumption based on lighting conditions. How it works. It detects ambient light levels and output values in LUX, helps determine whether the environment is bright or dark, works in combination with display settings to adjust screen brightness dynamically. So yeah, this sensor you can use. What it will capture, it will capture the light intensity of wherever you are, and with this you can actually do a lot of things. I have created a small demonstration how we can use this sensor in our Liquid Galaxy rig. So yeah, let's check this out. So first we have to implement it. For this, you have to again install a package. It's the light package. Now, the version I'm currently using will not allow the 4.0.0 version. As I said, always check the version, the minimum SDK version. So my current minimum SDK version is not 3.6. You can do two things here. You can just use a downgraded version, or you can increase your Flutter version using FVM. Yeah, just use FVM. It's a great tool. It will always come handy if you have FVM installed in it, because if you're working in many projects, different projects need different Flutter version. So you don't have to install it, reinstall it again and again. You can just use FVM and you can switch between them. So yeah, now let's quickly copy the version and paste it in your pubspec.yaml. Again, run the command flutter pubget. This will install the dependency here, light package. And now just quickly move to our light package screen. Yeah. First, just import the light package. After that, I have created a light object, like I have created a reference light. And here I'm instantiating a light object and using the light subscription to just capture the lux values from the sensor, and I'm storing it in our variable, and I'm just using that variable here so that I can show the light intensity. Just use a set state. Yeah. Apart from this, I'm also using block for the state management of this app. So currently I have used block for two things. One is the connection block that will establish the connection between the Liquid Galaxy rig and my phone. And the other is light sensor block that will just trigger the KML according to the light sensor value. So for this, let me show you. I have created here that if the value is below 10, just send the dark mode KML here, trigger dark mode KML, and if the value is greater than 50, just send the light mode KML. So yeah, this is how it will work. Let me quickly give you a demonstration. Just restart your app once. And for that, I need Liquid Galaxy rig. So let me quickly start my virtual machines. So yeah, as you can see, the rig is up and running, and I'll just connect my Flutter app with the rig. Okay, so now it's connected. Now let's first see the value that, okay, so it will first send a day mode KML. Let's first see. It should show the daytime in India. Let's see. Okay, yeah. As you can see here, it's showing daytime over India. So it sent the KML successfully. Now, if I change my light intensity value to, let's say, 0, what will happen is it will again center night mode KML. Yeah, as you can see, it's showing nighttime over India. And again, if I change the value to daytime, again, if I increase my value, it will again change to daytime here. So yeah, this was a small demonstration how we can use the light intensity value and send KML over it. So let me quickly explain how I did this. So for this, what I did, I triggered two KMLs according to the light value. So I just created two events. In block one is the trigger dark mode KML and other one is trigger light mode KML according to the light value. So in light mode KML, I'm just using a ssh.send KML function, and the dark mode KML, which contains the dark mode KML, and similarly to this. And yeah, it's sending the KML file successfully, as you can see here. So yeah, this was a small demonstration. Now let's quickly get to our PPT. I've seen the implementation of light sensor. Let's go to some real world application. So health and fitness apps, accelerometer and barometer are used in step counters, workout tracking, and altitude-based training, navigation and mapping, GPS, magnetometer, barometer, improve real-time location tracking and indoor navigation, augmented reality and virtual reality, gyroscope and accelerometer enable immersive AR/VR experiences for gaming and visualization, smart home and IoT automation, light and proximity sensors help in smart lighting, security systems and gesture-based automation, weather and environmental monitoring. Barometer and light sensor assist in real-time weather forecasting and adaptive display brightness. Gesture-based controls, proximity and gyroscope sensor allow touchless interactions with like swipe gesture or screen wake up on approach. So yeah, using inbuilt sensors in Liquid Galaxy, as I have shown you in the demonstration, where we can use the light sensor to send these KMLs. So yeah, and this was our application from which we control our sensors. So yeah, this was it. I hope you liked the video and thank you for watching.